Okay, hello. My my last topic will be surface tension. That's also something I have to introduce to you. It has something to do with viscosity, but I don't want to do too much here about surface tensions because it's a really complicated topic, yeah, and it depends very much on the chemistry of the fluids. Yeah. What is surface tension? We always have stresses. We have stresses, we have pressures in the fluid, we have stresses in the fluid, and you can imagine the stresses, the shear stresses inside the fluid depend really much also on viscosity. If we have honey or if we have water, it depends on the shear stress, on the stress inside the water, and the unit for surface tension is sigma, and we calculate it by Newton per meter. Yeah? Maybe you know it if you have a really full glass of water, you fill it with water and you get a structure like a hill or inside the glass. Yeah? And then it's a bit hilly on the surface of the glass, and that is more or less surface tension. Here's also some picture of boundary layer and capillarity. If we have really thin channels, yeah, small channels, and we put oil inside or we put water inside, the water will climb up the small channels. Yeah, they will climb up the capillaries, and this depends also on the surface tension of fluids. Yeah. Okay, here you see it. Yeah, we have here a pot of water. We have small pipes. We put it into the water, and the water will climb up the pipe because of the surface tensions. It can also happen that we have fluid that have other behavior. For example, here quicksilver. If you put pipe into quicksilver, the surface tension will act in the other direction. You will not fill so much quicksilver into this pipe. Okay, yeah, there's additionally something I want to introduce you. I think we're nearly over. It was a long lecture. I taught you a lot about fluid dynamics, about the properties, and before we come to the end, I want to show you that fluid dynamics, even if maybe in future we will not have so much gasoline engines, or maybe we will not have so much diesel engines, yeah. So you say fluid dynamics will not be so important anymore, but I can prove you. Here is a picture of fuel cell, and also fuel cells work with fluid. They work with water inside or other substances, and you need fluid dynamic knowledge to develop fuel cells, for example. Yeah? Okay, so we are at the end of our lecture. Let's have a look. I give you a short learning control, what you should have learned in this lecture. Maybe look at the slides, look at the exercises, look at the videos. You should know what are state variables, you should know what is pressure, what is density, what is viscosity. You should understand this, yeah? And you should understand what are fluids and how can they change with pressure and temperature, yeah? Normally from school you have not so much experience with this influence of the temperature on the fluid behavior, or this pressure influence. But this is getting more and more important now. Yeah? And you have to know how a fluid should interact with the surface, and you should know what is viscosity. You should also know what is compressible, incompressible fluid. You should know what is Newtonian, non-Newtonian fluid. This is something you have to understand before you start the following chapters.